These are different pictures of orbitals. Orbitals are electrons that travel in subshells. They are not orbits. They may sound the same but totally different things. Class S orbitals can hold up to 2 electrons. It cannot be higher than 2, so it can only be either 1 or 2. It's located on the left side of the periodic table. Helium is on the upper right of the chart, but it still counts as part of the S group. First 2 elements on each row, there is a total of 7 rows, so it would go like 1s, 2s, 3s, etc. all the way down to 7s. The group number that goes after the s is either 1 or 2 because that is how many the S group can hold. Class P orbitals can hold up to 6 electrons. It can hold no more than 6, so it can only be 1 to 6 only. It is located on the right hand side of the periodic table, split between Zn, Cd, Hg, Ga, In, and Tl. It has 6 rows and starts with 2p through 6p. The numbers that go after the p is either 1 to 6. Class D orbitals can hold up to 10 electrons. It cannot be higher than 10, so it can only be 1 to 10 only. It is located in the center with Se, Y, La, and Ac. It is separated from the S and P group. It has 4 rows and starts with 3D through 6D. The numbers that go after the D is either 1 to 10. Class F orbitals can hold up to 14 electrons. It cannot have more than 14, so it can only be 1 to 14 only. It is located at the bottom of the periodic table. It only has 2 rows and starts with 4F and ends with 5F. The number that goes after the F is either 1 to 14. By looking at the table, you start from seeing left to right. Starting with hydrogen, that is in the S group, and in the first row, then count how many S's are in the first row. There are 2, hydrogen and helium. It would look somewhat like this. 1s2. 1 defining the first row, S defining the S column, 2 defining how many orbitals there are. For example, let's try to find oxygen. First start with hydrogen. Look through the row to be 1s2. Now we're on the second row. Now we have 2s2. Yes, there is more. But the S group can only hold 2, and besides, you can't combine the group. Different group can get their own numbers, so now it would be like this. Then we go to the P group. On the second row, count how much you would have to go over until you reach oxygen. 1, 2, 3, 4. So that'll be 4. So your answer would be like this. 2p4.
The quicker way is to look at the end, the noble gases, and go on from there. For example, let's say we're trying to find iodine. I'm going to explain the longer way first. Starting from hydrogen, then move right. So first row will be 1s2. Then down a row, and it would be 2s2 because it's on the second row and it only has 2, and we can't combine with the p's. Then we go down a row. Now we go to the p's on the second row, so it will be 2p6 because there are 6 elements in the second row in the p group. Then we go to the left, and that would be 3s2. Then we move along the row, so that would be 3p6. Then we move back over here to the S group, so it will be 4s2. Then now we move to the D group. There are 10 elements in the row, so it would be 3d10. And we move along, and it will be 4p6. Then we keep on going down, and it will be 5s2. 4d10. Then there are 5 to get to iodine, so it will be 5p5. So this may look long, so I'm going to take you the quicker way. So start from the noble gases. So iodin's right here, so I will start with Kr. Then move on here, so it'll be 5s2. Then 4d10. Then 5p5. That's a quicker way because everything from Kr from hydrogen everything is the same thing, but a shorter version. The ladder method is simple. If you know the order, just draw the step ladder and diagonal arrows. But I'm going to teach you how to read it to put it in order. So you start with 1s, then move down because there's no other. So it'll be 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, and 5p. Now we're going to use the ladder method, which is this. You just write it in order, then draw the arrows. So it would go 1s, then the arrow touches 2s, then it goes through 2p, 3s, 3p, 4s, 3d, then 4p, 5s, 4d, 5p. So either way, but I think the step ladder is easier because it's just the same thing, except for you don't have to look at your periodic table to know it. Okay guys, hope that helped. Have fun in chemistry.
Frog, yeah!